So today's talk is about security with Ruby on Rails. So this is going to be a pretty basic talk. We only have half an hour, and I really can't do any justice to security in half an hour. So I'm going to talk about some of the basic kinds of attacks that happen against web applications, what Rails provides for you and what it doesn't, and kind of what you can do to put it within reach. So if you already know some stuff about security, this is probably not the talk for you. Just letting you know up front so you're not disappointed. And we're going to go pretty fast because we don't have much time. So here's your outlet now. I won't be offended if you want to go enjoy something else. But that being said, how many of you have apps in production right now? Ruby on Rails apps in production? Okay. How many of you have ever audited them or kind of checked to see if they're vulnerable to any kind of attacks? One, two. What did you guys find when you did that? Cross-site scripting. Cool. Rails 2? Yeah, okay. We'll go through that a little bit. What else did you find? Did anybody find nothing when they looked? Okay, good. You should always find something. You will always find something. Every audit you'll do some kind of thing to change or to look at. It may not be major, it may not be a earth-shattering thing, but they'll always reveal something. Our software is an evolving being, and it's really easy to introduce security flaws. So I want to talk to you about how they happen and kind of what to do about them. So we're going to cover things like cross-site scripting, cross-site request forgery, SQL injection, ideas around session management, and different things that go into play there. Mass assignment, if you remember the GitHub incident not too long ago with Rails, that's a mass assignment. Exception handling and notification, which is a thing you don't think about very often, but actually is really important to think about. Static analysis tools, so things that will kind of run through your site and give you some ideas. How many of you were at the Brakeman scanner talk earlier? Okay, so I'm going to show you. Brakeman is one of the things I'm going to recommend. Is Justin here at all? Didn't. Hey. Yes. So there's some more good ideas from the back there. So awesome tool. Everybody should be using. I'll give you more insight on that later. And also I'm going to give you some things to go look at if you want to learn more. So if you want to become a better developer with security kind of focus, I'm going to give you some resources to take a look at. They're not by any means comprehensive, but they're a good place to start. Because as developers, we should all be security focused. It is not IT security's job to make our apps better. It's ours. That's one of the takeaways you need to make sure of is a lot of security conferences talk to other security folks and not developers. But we need to change that. As a developer, it is your job to know these things. So luckily, Rails does a lot for you. And we'll see what that is. We're not going to cover some things today, so I'm not going to talk about like physical access to servers. I'm not going to talk about operating system configuration and firewall stuff. I'm not going to talk about configuration management and change. I'm not going to talk about compliance or PCI SOCs, any of that stuff. I'm going to ignore a lot of that. I might mention it, but I'm not going to cover it. That's not really in the scope of the time we have. So we're not going to go through any of that. It'll just be kind of app security focused. There's a lot here, but the good thing is Rails is actually pretty awesome at giving you a lot to work with and a lot of protection kind of right off the bat. How many of you are on Rails 2 versus Rails 3? How about Rails 2? Hands for Rails 2. System's been around for a while, kind of in production, going, that kind of thing? Or did you start with Rails 2 for some other reason? No answers? Quiet? Okay, end of the day. And so the rest of you on Rails 3 then? Okay. So we'll start with the cross-site scripting. That was one of the things that was mentioned, and it's really one of the biggest bugs on most sites. That's just, if you're going to find a vulnerability on a site, it's usually going to be cross-site scripting related at this point. That's one of the largest things people see today. The attack, and I'm going to kind of assume that we've never seen any of these attacks, so we'll just kind of go through what the basics are. These get a lot more advanced and a lot more technical than this. This is just the most very basic attack I'm going to cover here. So the idea is that you have some kind of form inputs on your system, and a user can submit an executable tag, a code, right? It's a JavaScript or something, and you store that in your database. And then when you render it back out and you show that data back, that code is executed if it's not escaped properly. So if you put this little alert in and somebody tries to render your name as like a user ID and you say my name is the script tag, that alert's going to pop up, right? This is completely harmless. But if somebody does something different, like pull down all the JavaScript that might hijack cookies, pull down JavaScript that does different things, right? The possible outcomes here, they can steal cookies, hijack sessions. You can redirect data to an untrusted source. So For a while, there was this thing called clickjacking that happened a couple years ago, where people were kind of intercepting clicks that you made based on JavaScript they pulled in that they stored on your server. So it was a small scripts tag, but it would actually load a JavaScript library into your DOM, and there was a lot of interesting stuff that would happen. People can deface your site completely. We've all made it so easy for people to do little hacks on our JavaScript by adding jQuery because it's nice and useful. They can just use that jQuery that's already there and render a different site, right? Because they can use JavaScript to rewrite the DOM completely. They can just clear out what you've got and deface your site, or render the same site with a couple of tweaks that gives them password information, that kind of stuff, right? And denial of service, right? They could JavaScript bomb your site, so nobody can access it. Everybody goes there and it just bombs out. Or we have browsers now that can stop script execution if you keep alerting over and over again. But it can be a big impact to your business. So there's potential outcomes. I'm not going to cover everything here. There's a lot of more advanced topics that come out of this, but these are kind of the basic ideas that come from this. So each one of these things is going to come with what you should do, what we can do to help kind of mitigate or prevent this going forward. So if you're in Rails 3 land, you can just kick back. You're actually in a pretty good place. Rails 3 introduced the idea of auto-escaping by default. So everything you put out is going to be escaped by default. If you use the default Rails stuff, or if you're using ERB and that kind of thing, you're going to get that escaping for free. If you're on Rails 2, it doesn't come for free. But there's a gem called Rails XSS, which is a backport of what's in the Rails 3 stuff that makes auto-escaping possible. Now it introduces some additional rendering overhead, because it runs through a whole different, it runs through eRubus. So you added some overhead. So if you're performance sensitive, there's another thing you can do, and that's adding the escape calls manually, the H calls manually. I don't recommend this because you're going to fail at it. That requires you knowing that you've done it to every single output you're going to render. That's really rough, especially if you have a big app and a lot of rendering, a lot of templates. You're bound to miss something eventually. So that's, if you absolutely must do that, sure, it works. I just recommend against it because it's hard to do something manually when you can automate it and be a lot more successful at it. So the one thing about Rails 3 that's important to remember, though, is third-party libraries can ruin this for you. Third-party libraries can tell people, hey, I don't want to escape things. You can say HTML safe. You can mark something as safe and just render it as is. A lot of these are kind of like wiki plugins or forum plugins, engines that are in Rails that have these little text areas that you can put a bunch of stuff in, and they want you to be able to put markup in the field, right? It's some kind of a markdown or text style, but they'll accept HTML, and sometimes it's not sanitized. They don't pull out JavaScript tags. They don't do a good job of cleaning up the data. They mark it safe, and then inherently your application is now exposed because of a third-party library. So you need to be careful when you include libraries about what they do, and so when it happens, you should audit that. Auditing, I'm going to tell you a little bit more about later. I'm going to talk about the different scanners we can run, and also just a nice little project by OWASP called the WebGoat project, which is kind of an exercise or set of exercises that are about hacking a site. It's a vulnerable site, and they walk you through how to kind of perform these attacks. It's a great tool. Everybody should go through it. They don't teach everything, but they teach you a lot of stuff you can use that against your website. So moving on, cross-site request forgery. This is another interesting thing. The idea there is that somebody can act on a site on, oh, I'm sorry, question.
Sorry, we just missed what the site was you talked about.
WebGoat. I'll have links to it in the slides. I'll talk about it again a little bit later. So cross-site request forgery is, in essence, somebody being able to act on your behalf that isn't you. That's kind of the idea of the attack. And so the scenario here we'll play is, so let's say you're a bank, and a customer has logged into your bank. They've got their bank account open and logged in. They open another tab in their browser. They visit other site. Other site checks for this. They can actually send a request to the bank and say, hey, transfer funds from this account to my account. And my account being the thing I'm logged in as, right? Because I can act as that user, right? I haven't verified the authenticity of the request. I haven't said, make sure that the person submitting the form is submitting it through my site, right? Where I'm just posting a little JavaScript piece of data there. And so this kind of example is very contrived. It gets a little more complicated than this, but this is the idea, right? I'm going to make a request on behalf of you, not being you, but knowing that but just kind of using the fact that you're logged in to this site. How many of you have ever used Working with Rails? Ever seen that site, Working with Rails? It's put up several years ago So for a while, there was a vulnerability, and a lot of people took advantage of it, where if you read somebody's blog, they would put a little iframe thing in there, a little JavaScript tag in that would post to working with Rails, and you would recommend them on working with Rails and say and check the box that you read their blog because you were reading their blog and you were logged into working with Rails. So that's an example of a cross-site request forgery attempt successfully happening, and they ended up fixing it. And they took away all the recommendations that everybody got, unfortunately, too. But that's the kind of thing that happens, right? The outcome of this attack is that somebody can act on behalf of you without really being you. The cool part is Rails does this for you. It's actually on by default, too. And it's been on by default since Rails 2 something. But that's what this protect from forgery thing is. If you've ever seen this protect from forgery inside of Rails, that's what this is there for. That's what the reason for this being around. And what it will expose is this authenticity token. So how many of you have ever tried to do some JavaScript stuff on your Rails app, and you got a weird exception back that said invalid token, invalid authenticity token? Right? That's this CSRF protection happening. So you have to be able to submit that authenticity token back with the form, otherwise it's not valid. Rails will say, that's a bogus request. And that's what that protection is about. It's about making sure that the thing that it just presented to you, you're giving it back to Rails and saying, yes, I'm coming from the page you just showed me, versus coming from some third party. So again, this goes a little deeper, but the idea is that it's on by default for you. So what you really want to do is make sure that this is set. So go into where this is set, make sure it's there, make sure it's on, make sure it's not commented out, and flag any changes to the file that contains this code, right? You want to know when this changes. Don't ever let somebody turn this off. It's tempting when you're doing this JavaScript and all of a sudden you're getting back these exceptions to just turn this thing off. Screw it, I'll just turn it off, right? It's there for a very good reason. You want it on, right? You want to work around any issues with JavaScript and do it right. So it's tempting for some people to turn that off and not understanding the full ramifications. So auditing this and making sure that this doesn't ever change or ever get commented out is a good idea, right? You can put a simple little test in that tests for cross-site request forgery if you want to go that far. But I think just auditing your version control and making sure that doesn't change is good enough. So we're going to go to SQL injection. SQL injection is actually kind of a little bit older at this point. It's been around for a while. People have, for the most part, kind of started to nip it and do away with it. But there's been some interesting hacks that were SQL injection related, especially around Anonymous and lulzsec and the Sony Corporation and things like that over the last year. They actually were getting in via SQL injection in some cases. So the idea with SQL injection is that you're just going to confuse the SQL server into giving you data by passing it through the application. So this attack I have here is, or the query I have here is basically saying, select me from the users where true. It's kind of what everything evaluates to. So do it. And the idea is that the SQL server is going to say, okay, I'll give you back all the users. Not just your user, but I'll give you back everything. So you can steal data. You can change data. Right. Once you can execute SQL, once you figure out a way to kind of manipulate the query in such a way that you can execute SQL, then you can do whatever you want. Like you have full access to the database. You can drop tables. You can change data. You can access information you shouldn't. The world is your oyster at this point. So I'm going to have the contrived example here of passing in the parameters straight to a query. So this example actually I don't even think works anymore because I think params are escaped by default. But the ramifications of this really are unauthorized access to data, tampering, defacing. Right? So if you're a content-driven site that's database-driven, right, you can stuff new content in that would render a blog post or something like that that would then again deface your website. You could add a cross-site scripting attack, or just a scripting attack where you pull in additional script tags. Like you can kind of change anything, right? You have control over that. So the possibilities are kind of endless based on, well, not endless. They're based on the constraints of your system. But if you allow those kind of things to happen, then the outcome's much worse. The best part about this is Rails is awesome at this. Every active record query by default just handles this. It quotes everything. There's a method in active record base on connection called quote. It happens for everything. If you're using the standard Rails calls, you're good. If you start putting in raw SQL and string interpolation, then things get bad, right? It's up to you, right? It's a matter of how you deal with things. So if you're ever dropping to SQL execute or find by SQL or any of those kind of conventions, make sure that you're going to use a prepared statement and let the SQL language take care of it for you. Don't ever directly interpolate a string into a SQL query. That's kind of uniform a bad thing to do. So if you've ever seen find with conditions and then you have a little question mark and then you pass it the second parameter, that's that prepared statement. That's going to take care of that for you and make sure things are in the right place versus just putting that string in directly. So never accept input from a user directly and put it as a statement to your database. That will always yield you a bad result. And that's behavior among anything, any framework, anytime you're doing a SQL-driven app. So Rails takes it that step further. A lot of times it will escape params for you. It will take and quotes, active record calls. That stuff is done really well. And so there have been lots of attention paid to active record over the years around different kinds of calls, and I think they've got it pretty well in order. Even that's all the way back from Rails 2.0, I think, and up. There were patches for like limit and offset and those kind of things, kind of edge case queries, but those have all been patched up too. So you're in a good spot with SQL injection. Be careful. Obviously, it's a double-edged sword. You can always put yourself into a corner, but it's actually pretty hard in Rails to get yourself there. So one of I think the hairier problems in this space is about session management and how we deal with sessions. Session hijacking, session replay can be a big problem. How many of you ever heard of the tool called Firesheep? What did it do? Yeah. Do you know how it worked? Like, what happened? What was the...
Copy the cookie.
Yeah. So you would just listen on the network. If you went on like a public Wi-Fi or any public network, the cookies were transmitted in plain text. They were in HTTP, and you just listened and grabbed it and just replayed it and used it. You stole it.
It would show you their pictures, too.
Yeah, you can do anything with it, right?
It would show you their Facebook pictures so you know who you were
Yeah, yeah. So FireCookie did a bunch of stuff, or Firesheep did a bunch of extra stuff to do that, to help you out there. But I mean, the principle here was, or the concept was, people send session cookies over HTTP. And that's just in plain text. You might even have a login over SSL, but they would still send the cookies in plain text. Now, that doesn't do anything, right? Because then it doesn't matter. Like, yeah, okay, you couldn't steal their username and password, but but you didn't have to because you could steal the cookie, and then that was just as good. It was obviously for a limited time, and there were limits on what you could do and how long you could do it for. But at the same time, you still had access. And so this is easy to do, right? There's nothing Rails can do by default to fix this for you. This is more of an active thing. If you let your cookies travel over plain text, or if you let your cookies be accessible by JavaScript, which is the HTTP-only cookie idea, they can be hijacked. So a cross-site scripting attack, if you let your cookies be accessible via JavaScript, can steal a session and then pull it back to somebody else and hand it over to them. So those ideas transfer. Cross-site scripting actually builds on this, and you can create session hijacking attacks based on stored cross-site scripting attacks. So these attacks all work together and compound into larger scale attacks. And so it's really simple to do, right? This is just like you grab a network sniffing tool, grab Wireshark, grab whatever, and just listen and watch for HTTP requests and filter them and just look at what happened. The URLs are there. You can actually filter for a URL and just like grab it. It's really simple. Firesheep made it like dead simple. You just turn it on and it just starts grabbing things for you. It's really, really easy to pull off. So the outcomes here is that the session that you're given is what you have access to, right? So if somebody steals that session, they can do whatever you could do. If they happen to steal an admin account, then they can do the admin stuff. I mean, that's all there. It's accessible to them. And that's rough, right? That's brutal. There is an easy fix for this, but it requires more work than the rest of the things I've talked about. And that's actually two things, right? You're going to have to buy an SSL certificate and put it on for your site. That's nothing the Rails community can't do this for you. You have to set this up yourself. You can do a self-signed cert, but then again, there's all the implications of doing that and people not trusting you because of it. So sites are pretty cheap at this point. You need to buy a certificate. You set up your web server to support it, that kind of thing. There's administration steps. There's more legs here. It's not hard to do. It's just extra steps. But inside your Rails app, you want to actually make sure that you send the cookies over that secure channel. And you can take a step further and say HTTP only true too, to make sure that cookies can only travel over HTTP, and you eliminate that class of JavaScript session stealing as well. So I usually say do both, right? Let both of these things happen to kind of double up on your protection. So this is your settings in Rails. There are different versions of Rails have different settings, so you want to look and see which version of Rails they have different ideas and different syntax, but it's mostly the same. And so links to these slides will be up later, so if you want to copy this, you can look at the Rails guides too. They show you how to do it. And also, see XSS protection, right? If you escape, if you protect yourself against XSS and you don't do HTTP only, then you can at least stop that class of attack. So make sure that you're, not building or allowing compound attacks. Rails 3.1, I think it was, started a configuration option that says force SSL. So you can force authentication via SSL. I'm pretty sure it's Rails 3.1 or maybe 3.2. I can't remember which version. But that appeared as well as kind of an answer to a lot of these things that have been happening around hijacking. And so another note about sessions. Sessions are really tempting because they're this place to put shit. But it's actually difficult because that data is not encrypted. It's encoded. If you put sensitive data in a cookie, somebody can decode that cookie. It's base64 encoded, that's it. That's all there is to it. It might look encrypted, but it's not. I think some people have worked at like encrypted cookie store kind of ideas inside of Rails. I wrote one a long time ago, but it didn't ever take off. But as a rule of thumb, you don't store anything that you can't live without in the session, right? It's a user ID is about what you should put in your session. That's it, right? I mean, if you have to, that's fine, but work around it. Because that data can be turned around and used against you. Session tampering is pretty hard. That whole secret thing you put in your Rails app on the configuration works against a hash, and the session cookie is hashed then. And if you modify the session data, then the hash doesn't match up anymore and it gets rejected. So session tampering is hard to do, but it is easy to decrypt the session. So make sure that when you're storing things in the cookie store, that you're not putting sensitive data in there. And that's not really anything you can fix. It's just a practice. So mass assignment. This is the big one. This is the noisy one. How many of you saw the GitHub attack? I think we all did, right? For those of you that didn't, that somebody was able to, via a mass assignment attack, add themselves to the Ruby on Rails project on GitHub, and then make a small commit that said, hey, look, I'm doing this. And it was via this attack. So when we create a model on Rails, by default, all attributes are accessible via creation. So you type new, type create. Whatever you pass into that create statement or that new statement is automatically available to you without any additional ramifications. So this is what makes possible this whole create, and then you just pass params down. A really simple way of kind of building out CRUD. The problem is that it takes everything without any restriction. So if we consider creating a params with users, so somebody signs up in the sign-up form, and so you have like first name and middle name and last name and phone and email, and they're all required except for middle name. You don't require that. So your form's not going to bounce if somebody puts the middle name in or doesn't put a middle name in, or even if they don't send it down, right? That doesn't matter. So there's this wonderful tool that, the best hacking tool ever for web apps. It's called Chrome or Firebug. You just kind of click on the inspect element and you change the user middle name to user admin, and you type true in the box and you hit enter. And all of a sudden, now you're an admin. You've made yourself an admin through the sign-up form, right? It gets worse too, because sometimes JavaScript will restrict what gets down to the page, and they'll kick that kind of stuff out. But then you just put a little proxy in, a little thing that stops the request from happening after the server submits it. And then you can modify the params and then pass them down to the server. Or you can just hit curl, right? You can say curl user admin equals true and post it to your app. And now it'll take that data and just use it. So you can become an admin. You can do all kinds of, anything that's accessible via an active record field is accessible via your model and these form assignments. So this is one of those things that somebody can just start doing things, so changing things. It's mostly, it's all via a point of user interaction. So users entering something into your system, and you have something in your form that's not required, right? Anything that's required is going to get bounced if it's in the wrong shape. Hopefully your validations are good. But assuming your validations are good, anything that's not required is kind of open to this mass assignment attack if you haven't protected yourself. So the fix here is very simple. I'm putting one half of the idea here up because the other half I think is not as valid, but it's ad accessible. What you're saying to Rails or what you're saying to the model is I'm only allowing these fields to be accessible via mass assignment. So if I hit new or create and I put anything else in, it's going to ignore them. It's not even going to set them. So if you've used some authentication frameworks like Devise or OmniAuth or those, they might generate a model that has that ad accessible thing right in place there. That's what they're doing, is saying, no, you're not allowed to mess with anything but these things that I've deemed necessary. And you have to change that to make it work. So I don't know how many of you went to the console and hit create and put a bunch of stuff in, and you're like, why didn't this work? And you're like really frustrated, and you look back, and that's why. It's this thing, and just ignoring it. There's something called adder protected, which is a blacklist versus a whitelist. The idea is whitelisting is always better. Only allow what you want to allow versus unallowing anything you don't want to happen, right? It's easier to miss something, right? It's much, much better to only allow the things you want that are necessary. You're much less likely to make a mistake that way. So, on to the thing that people don't think about, but it's super duper important. Logs are there's lots of data in logs. There's more data in logs than you'd ever imagine people would actually want. There's also a lot to be had about exceptions. So, how many of you think that when somebody goes to your site and hits something and you hear the oops, something went wrong, there's a major problem there? There's not enough hands up going up right now. Are you guys sleeping or? Okay, I'm gonna ask this question one more time. When somebody goes to your site and you see, oops, something went wrong, how many of you think there's a major problem here? Oops, are throwing things at people. Jesus Christ. So this is huge, right? What does this tell somebody? I've been able to input to your system and confuse it. I've been able to break it down. As an attacker, that's like a gold mine. I've just found a place that I can poke at your system and it fails. Usually that means there's something else I can do if I keep trying. Now I have a more focused area to attack. I'm going to keep going. I'm going to keep going, I'm going to keep going, I'm going to keep going, and I'm going to try and see what else I can do, right? If attacker, and people usually use a scanner. They can use a little, hit a button and scanner, and here's all the pages that had a 500 error on them. Okay, great, now I have a list of things to attack, right? This is just a footprint mechanism. You should never expose 500s. I mean, things happen. We'll always have mistakes. But you should be very careful, right? Run these scanners and find out where these 500 exceptions occur. And when they happen, when a tree falls in the forest, you want to know it fell, right? You want to hear it, right? You don't know it happens if you're not listening. So you want to have an exception notification tool to tell you something happened. You want to fix them right away. It's really important. It seems strange. It's, oh yeah, an error, I'll get around to it. But if an attacker is after your system, it's really telling them I have something I can aggressively attack. If you're stopping all these kinds of requests and you're behaving like normal, you're gonna go somewhere else because it's easier targets. There's lots of easy targets on the internet everywhere. But you want to be sure to try to kind of thwart those as soon as they happen. Like they are a big deal. Like you should always treat that as a big deal. But in the notification space, you want to be careful too, right? There's exception notification or exception notifier, I think, that'll send you an email. And there's this really cool service used to be called Hopto, now it's called Airbrake. It's great because it gives you a nice UI and it lets you look through exceptions and mark them off as you fix them or you've addressed them. But there's a big fundamental flaw here is that you don't own the data, right? Somebody else does. And unless you turn it on, the information doesn't travel over SSL. So it doesn't travel over a secure channel. And this is exception data, the stack traces to your system. There's a lot of juicy stuff in there. And I'm not saying anything about the exception or the security around Airbrake, but if they have a breach and your data is stolen, your information is only as safe as their security, right? So now you've extended your vulnerability out to somebody that you don't control or own. So if it's really sensitive data, if your application is processing lots, for instance, I work at Groupon. There's a lot of information there. You want to be careful about who owns your data. And because it can be used against you. And sometimes you put things in your logs that you don't even mean to put in, like maybe passwords or credit card numbers, because you didn't filter them, right? There's a whole different class of what you should and shouldn't put in your logs. But it's important to, if you don't own your data, know that you don't own your data and accept that as a risk. So I'm getting close to running out of time here. So, I mean, the big thing here is that when people see these 500s, they use them against you. And stack traces are actually expensive. They're really expensive. They cost a lot more than a regular request unless you have lots of database hits. But if somebody sees it, they can just pump it over and over again and actually cause denial of service attacks because you're so busy rendering exceptions to Airbreak or sending them out via email. Your system's tied up doing things other than serving requests to users. Denial of service attacks can kind of bubble up because of this. So test, right? This is about getting people to click to the website, find bad information, monitor your logs. Like monitor, always monitor. How many of you guys just like Splunk or any of these kind of things to mine data? Like, this is really important. You want to watch your logs. You want to know what's happening in your system. It's not good enough just to put it in production. It's not in production until you know what's happening. Just saying go cap deploy is not production. Like until you have a grasp of who's doing what, when, and how, you're not really in production because you have no idea what's happening. Metrics are important. Visibility in your system is important. And that's something we all forget is we're so hurried to ship, we're so much in a hurry to ship it, we forget to do the things that are important. So when you do hit cap deploy, make sure that you have some stuff behind that to support your install and your infrastructure. Because otherwise you're totally blind. And you could be hacked and nobody would know it. Like it's impossible to even find out. So, static analysis tools. Can't read that. Anyways, these are screenshots of Brakeman. Snippeted screenshots that I took in sections. I will give you a link to these slides. This is the tool you should all install and run on your system. It's dead simple to start going. It uses static analysis to look through your code. Well, static analysis is kind of a wavy term with Ruby. And 1.9 there's Ripper, but in 1.8.7 there's Ruby inline. It makes a little AST and then walks the AST to determine what's happening, what calls are being created, and how. It's a structure tool. It's very cool. Brakeman's a great place. It's evolving. There's a lot of good work going into it. It's invaluable. There's a Jenkins/Hudson plugin for it, so you can have it, hook up via your build. There's no excuse. It's really easy, and it produces a great report. And it makes you aware of mass assignment vulnerabilities and all the stuff that you should be on the lookout for. It tells you what you did wrong. It's great. So go install it. Not right now. Don't kill the network. But it's really easy. So brakemanscanner.org is the website. I'll show you the links in a minute. But to go learn more, because we're out of time here, the WebGo project from OWASP is kind of a nice training exercise. It'll help you work through problems. It'll help you become a better kind of security-focused person. It'll teach you some of these attacks that I've been talking about and how to execute them. They go into much more detail than I did here, and you'll become a better developer because of it. Try this on your site, not in production. Don't screw things up that way, but play, encourage yourself, learn more. Security is a really important thing to learn as a developer, and it's a good thing to go by. The book, Web Application Hacker's Handbook, has a whole website and stuff around it. It's great. It's by a group of people who produced the Shellcoder's Handbook quite a while back, which was a great tool for other kinds of hacking. There's a book kind of in progress right now. It's going to become an open source Creative Commons book called Practical Software Security. I'm involved in that. Mark Curfey. Justin, are you involved in that too?
Yes.
Yes, Justin's involved too. I think he's actually writing the static analysis sections. It's a work in progress, right? It's not to really be checked out quite yet, but it's keep your ear to the ground. There'll be some very developer-focused content in there. The whole idea is to empower developers, not security people, to fix these software problems. That's the focus. And practice. Try new things. Try everything. Get better at this stuff because it's really important. References. This presentation, which will have all these links in it, is on GitHub. It's called Securing the Rails. There's an HTML file in there, which is just what I'm showing you here. The rest of it is a bunch of weird Emacs org mode garbage you don't want to worry about. But if you want the slides, you just kind of open up the HTML, and they're good to go here. The Ruby on Rails Security Guide, the Brakeman Scanner, the Practical Software Security Book, the OWASP Top 10, which is a list that OWASP provides about the top 10 web vulnerabilities as are reported. So we covered actually a bunch of them in this talk, but there's others I didn't. And then the WebGo project. So I'll leave this here while we're kind of shutting down. And if you have questions, come grab me because we are out of time. Thank you.